let me move forward to our reproducibility challenge. And that challenge essentially asked the question of whether it's hard to reproduce a good paper. And I want to begin with thanking the author of the paper we used for our challenge. And that was really important to us that we worked together and that he provided his codes and his code for us, and that was really, really useful. So this paper was published in Diabetes Care, as Patrick said, a decent journal, and focused on investigating the effect of glucagon-like peptide 1 receptor agonists on the chronic lower respiratory disease exacerbations in patients with diabetes. And that was a really nice paper, well written, with the nice figures showing a rather large effect. So we decided to reproduce it. And on the last symposium, we had 9 teams of highly qualified experts of OHDSI fellow members. And we given them the pre-populated atlas templates for cohort definitions. And we put the concept sets that we already created in it. And we gave them a full day to reproduce the cohorts for target, comparator, and outcome cohorts based on the paper and supplementary materials. And in this very specific talk, I would like to focus on the target cohort. And essentially, you can see a sample of the text that describes the cohort. And to orient you in the cohort that we'll be using throughout the talk, we looked at the patients more than 70 years old with type 2 diabetes and CLRD who started on GLP-1 receptor agonist treatment, which has to be an add-on treatment to another antidiabetic drug. And then we have a bunch of exclusion criteria like type 2 diabetes and other conditions. So you can see here that really the whole cohort is described in, I would say, 5 sentences. And we went on with creating the master cohort definition out of this text and some supplementary materials. And this 5 sentences, in fact, turned out to be a huge cohort definition which specified the cohort entry, the cohort exit. So we had to specify the start and the end date and duration and all of the right censoring criteria. And we also had the exclusion and inclusion criteria, 10 in total. And you can see that each of the inclusion criteria here on the right actually had also the start and the end date, the concept set linked to it, and also multiple Boolean and temporal logic pieces connected to this criteria. So in fact, each criteria was described extensively, and you can see a small sample of one of the criteria on the very right here. So in fact, these 10, again, lines were represented as a full definition, which appeared to be much, much longer than that. And that we created with the first author of the paper was Yasser. And we also asked the teams to implement it. So we had 9 different GLP-1 receptor agonist user cohorts. And when we asked our teams were really confident that they can translate the logic of the paper into the right cohort definition. So they really thought that they can get it right. And let's take a look how many criteria they actually got right. So this picture essentially represents, you have the teams and you have the number of deviations in the criteria. Again, we have 10 criteria, and we can see here that, in fact, on average, teams got 6 criteria out of 10 wrong. And here, I'm saying wrong, but in fact, that does not represent that they weren't able to understand something, but rather that represents that the description was not sufficient to interpret that in an unambiguous way. And if you look at the colors of the boxes that represent different criteria, you can see that different teams, in fact, had different criteria wrong. So it wasn't like they got something very specific wrong. In fact, they had all of the different deviations from the overall picture. And if we look at the very specific criteria to see if there are any patterns, maybe, we would see that there are very specific criteria that were easy to get. So this very first line, easy to reproduce, points to the two criteria: 365 days of prior observation and age at more than 17 at the index date. And all of the teams got it right. So there were 0 deviations from the master implementation. And then, of course, you would think that these are the things that are very easy to get right. But then when we get a closer look to the other criteria, we see that it's not that easy to, for example, represent type 2 diabetes or CLRD diagnosis. And for example, for CLRD diagnosis, none of the teams were aligned with the master implementation. And that was because those criteria were really complex criteria with the multiple sub-elements. So we had conditions, we had medications, all of them had to be somehow connected to the different types of visits. So that it was a really complex construct written as a free text, which made it really hard to properly reproduce those criteria. Then we had criteria like not pregnant, which is in fact a phenotype on its own because it has a clear start date, a clear end date, and you have to somehow define this time interval, which in fact is a phenotype. So none of the teams, again, really reproduced these criteria similar to how it was done in the master cohort. And then we also had this add-on therapy where a lot of teams had deviations from the master implementation. And that again represents this complex temporal logic where you have to define how exactly the drug overlaps. And that can be hard if you don't really know what the author meant and if the author didn't really spend a whole page discussing how it was done. And well, the next question is, okay, we saw that there were a lot of deviations, but do we get any influence on the patient selection? Maybe we just get just the same patients regardless of how many deviations we had in the implementations. And first of all, let's take a look at the cohort overlap. So what you see here is, again, per team, you have a number of patients in the master implementation, in the team implementation in blue, and the overlapping number of patients in yellow. And you can really see that there were teams that actually read the paper, read the supplements, spent a day replicating the cohort. They were really smart. They really took their time to reproduce the criteria, and they got 0 overlap in patients. And on average, you see that the overlap is really small, and the maximum overlap we get is the 35%, which in fact is only about a third. So even if you get a lot of criteria right, yet the patient overlap appears to be really small. And if we look at the individual patient characteristics, which I think is also interesting, what you see here is the heat map of the standardized difference of means, and the white spaces are those that are standardized difference of means less than 0.1. And you can see, for example, those yellow squares in asthma, which indicate that there was a huge difference in baseline prevalence of asthma in the team's replications compared to the master implementation. And asthma and chronic obstructive lung disease are two conditions that are the core conditions to the whole research question, because we study CLRD exacerbations. So that's really important to look at these characteristics to see how different design choices made by the teams influence the patient characteristics. And there were also others like glaucoma that showed no difference between the master and the team's implementations, because everybody pretty much included diabetic patients. So it's really, bottom line here is that when we're replicating a study, it's also important to look at the patient characteristics, not only the patient counts, but also because it also gives us this useful information. And to sum it up, I want to say that first of all of us tend to underestimate the amount of information that is needed to reproduce a study, and we see this blob of text and we think that we can do it well, and we absolutely cannot. And also free text is not very suitable for representing the complex criteria. You cannot really describe the temporal connections and the other logical connections using free text alone. And using the figures and supplements sometimes only confuse you and does not add clarity. So given that we have a common data model, we have the open source tools, and we have the common environment, in OHDSI we can really share code and we can try to enhance reproducibility of our work by providing this code that will allow us to represent the study in an unambiguous way.